Hello everyone and welcome back to the channel. I am so happy to see you here today. If you are new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today we are going to learn about a topic that is very practical in further mathematics and additional mathematics. We are going to talk about the application of differentiation. This lesson is suitable for SHS 2 and SHS 3 students. Now, I know that when you hear the word application, you might feel a little nervous. Many students find this topic challenging because it combines calculus with real-world problems like motion and shapes. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 4 periods worth of content here, which is 160 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long, so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to use the derivative as a gradient function to find slopes at specific points. You will learn how to find the equations of tangents and normals to a curve. You will learn how to solve problems involving rates of change and small changes, which is also called approximation. You will learn how to locate and classify stationary points like maximum, minimum, and point of inflection. You will learn how to sketch curves using stationary points and intercepts. And finally, you will learn how to apply differentiation to linear kinematics, which involves displacement, velocity, and acceleration. That is a lot, but we will take it one piece at a time. Let us start with section 2, the gradient function. What is the gradient function? The derivative, which we write as dy dx, is called the gradient function. It gives the gradient or slope of the curve equals f of x at any value of x. Think of it like this. If you're walking on a curved path, the gradient tells you how steep the path is and exactly where you are standing. There are 3 important things to remember about the gradient. If dy dx is greater than 0, meaning it is positive, the function is increasing. The path is going uphill. If dy dx is less than 0, meaning it is negative, the function is decreasing. The path is going downhill. If dy dx equals 0, the tangent is horizontal. This is a stationary point. The path is flat for a moment. Let us look at example 1, finding the gradient. The question is, find the gradient of the curve y equals x cubed minus 2x at the point where x equals 2. Step 1. Find the derivative dy dx. We use the power rule. X cubed becomes 3x squared. Minus 2x becomes minus 2. So dy dx equals 3x squared minus 2. Step 2. Substitute x equals 2 into the derivative. We want the gradient at x equals 2. So we put 2 where x is in the derivative. Gradient equals 3 times open bracket 2 close bracket squared minus 2. 2 squared is 4. 3 times 4 is 12. 12 minus 2 is 10. Answer, the gradient is 10. See? First find the general gradient function, then plug in the specific x value. Do not plug x into the original equation. That gives you the height, not the gradient. Now let us move to section 3. Equations of tangent and normal. What is a tangent? A tangent is a straight line that touches the curve at a point and has the same gradient as the curve at that point. it just skims the surface. What is a normal? A normal is a straight line perpendicular to the tangent at the point of contact. It sticks out at a 90-degree angle. Here are the formulas you need. Let m be the gradient of the curve at the point open bracket x, 1 comma y1 close bracket. The equation of tangent is y minus y1 equals m times open bracket x minus x1 close bracket. The equation of normal is y minus y1 equals negative 1 over m times open bracket x minus x1 close bracket. Notice the negative 1 over m. This is the negative reciprocal. If the tangent gradient is m, the normal gradient is negative 1 over m. They are perpendicular friends. Let us look at example 2. Tangent and normal. The question is, find the equations of the tangent and normal to the curve y equals x squared at the point open bracket 2 comma 4 close bracket. Step 1. Find the gradient m at x equals 2. First, find the derivative. Y equals x squared, so dy dx equals 2x. Substitute x equals 2. M equals 2 times 2, which is 4. So the gradient of the curve is 4. Step 2. Equation of tangent. We use the formula. Y minus y1 equals m times open bracket x minus x1 close bracket. Our point is open bracket 2 comma 4 close bracket. So x1 is 2, y1 is 4, m is 4. So y minus 4 equals 4 times open bracket x minus 2 close bracket. Expand the bracket. Y minus 4 equals 4x minus 8. Add 4 to both sides to make y the subject. Y equals 4x minus 8 plus 4. Minus 8 plus 4 is minus 4. So the tangent equation is y equals 4x minus 4. Step 3. Equation of normal. The gradient of the normal is negative 1 over m. Since m is 4, the normal gradient is negative 1/4. Use the formula again. Y minus 4 equals negative 1/4 times open bracket x minus 2 close bracket. To remove the fraction, multiply the whole equation by 4. 4 times open bracket y minus 4 close bracket equals negative 1 times open bracket x minus 2 close bracket. Expand 4y minus 16 equals negative x plus 2. We usually write this in general form. Add x to both sides. Subtract 2 from both sides. X plus 4y minus 16 minus 2 equals 0. Minus 16 minus 2 is minus 18. So the normal equation is x plus 4y minus 18 equals 0. Answer. Tangent is y equals 4x minus 4. Normal is x plus 4y minus 18 equals 0. Please write that down. Notice how we use the negative reciprocal for the normal. That is the key difference. Now let us move to section 4. Rates of change and small changes. Differentiation measures how one quantity changes with respect to another. If we're looking at change over time, we write dy dt. This is the change in y per unit time. If we are looking at change over space or x, we write dy dx. This is the change in g in boy unit x. There's also a concept called small changes or approximation. For a small change in x, which we denote as delta x, the corresponding change in y, denoted as delta y, can be approximated using the derivative. The formula is delta y is approximately equal to dy dx times delta x. Think of it like this. If you know the slope dy dx and you take a tiny step forward delta x, you can estimate how much you went up or down delta y. Let us look at example 3, small changes. The question is, the side of a square is measured as 5 centimeters. If there is a possible error of 0.01 centimeters in the measurement, Estimate the possible error in the calculated area. Step 1. Write the formula for area. Area A equals x squared, where x is the side length. Step 2. Find the derivative dA dx. The derivative of x squared is 2x, so dA dx equals 2x. Step 3. Use the approximation formula. We are given x equals 5. The error in measurement is delta x equals 0.01. We want to find delta A, the error in area. Delta A is approximately equal to dA dx times delta x. Substitute the values. Delta A is approximately 2 times 5 times 0.01. 2 times 5 is 10. 10 times 0.01 is 0.1. Answer: the estimated error in area is 0.1 centimeters squared. See how useful this is? You do not need to calculate the new area and subtract. You just use the derivative. Now, let us move to section 5, stationary points. What is a stationary point? A stationary point is a point on a curve where the gradient is 0. This means y dx equals 0. The curve is flat at this point. There are 3 types of stationary points. Number 1, maximum point. The curve goes up, then down. It looks like a hill. The second derivative, d squared y dx squared, is less than 0. It is negative. Number 2, minimum point. The curve goes down, then up. It looks like a valley. The second derivative, d squared y dx squared, is greater than 0. It is positive. Think of a smile. A smile is positive. A minimum is a smile. Number 3, point of inflection. The curve flattens but continues in the same direction. The second derivative equals 0. Here is the method to classify them using the second derivative test. Step 1. Find dy dx and solve dy dx equals 0 to find the x coordinates. Step 2. Find d squared y dx squared. Step 3. Substitute x into d squared y dx squared. If the result is positive, it is a minimum. If the result is negative, it is a maximum. Let us look at example 4. Finding stationary points. The question is, find and classify the stationary points of y equals x cubed minus 3x squared minus 9x plus 5. Step 1. Find dy dx and set to 0. Differentiate the function. X cubed becomes 3x squared minus 3. X squared becomes minus 6x minus 9x becomes minus 9. Plus 5 becomes 0. So dy dx equals 3x squared minus 6 minus 9. Set this to 0. 3x squared minus 6x minus 9 equals 0. We can simplify this by dividing everything by 3. X squared minus 2x minus 3 equals 0. Now factorize. We need numbers that multiply to -3 and add to -2. Those are -3 and +1. So open bracket x minus 3 close bracket times open bracket x plus 1 close bracket equals 0. So x equals 3 or x equals -1. These are the x coordinates of the stationary points. Step 2. Find corresponding y values. We need the full coordinates. At x equals 3, y equals 3 cubed minus 3 times 3 squared minus 9 times 3 plus 5. 3 cubed is 27. 3 times 3 squared is 27. 9 times 3 is 27. So y equals 27 minus 27 minus 27 plus 5. 27 minus 27 is 0. 0 minus 27 is -27. -27 plus 5 is -22. So the point is open bracket 3, comma, -22, close bracket. X equals -1. Y equals -1. Cube minus 3 times -1 squared minus 9 times -1 plus 5. Negative 1 cubed is negative 1. Negative 1 squared is 1. So minus 3 times 1 is minus 3. Minus 9 times negative 1 is plus 9, plus 5. So y equals negative 1 minus 3 plus 9 plus 5. Negative 1 minus 3 is negative 4. Negative 4 plus 9 is 5. 5 plus 5 is 10. So the point is open bracket negative 1 comma 10 close bracket. Step 3, classify using d squared y dx squared. First, find the second derivative d. Y dx was 3x squared minus 6x minus 9. Differentiate again. 3x squared becomes 6x. Minus 6x becomes minus 6. Minus 9 becomes 0. So d squared y dx squared equals 6x minus 6. Now test the x values at x equals 3. 6 times 3 minus 6 equals 18 minus 6 equals 12. 12 is positive. Positive means minimum. So open bracket 3, comma, 2022, close bracket, is a minimum point at x equals negative 1. 6 times negative 1 minus 6 equals negative 6. Minus 6 equals negative 12. Negative 12 is negative. Negative means maximum. So, open bracket negative 1 comma 10, close bracket is a maximum point. Answer. Maximum point at open bracket negative 1 comma 10, close bracket. Minimum point at open bracket 3 comma negative 22, close bracket. Please write that down. Always find the y value and always test the second derivative. Now, let us move to section 6, curve sketching. To sketch a curve accurately, you need to identify key features. Number 1, intercepts. Where does it cross the axis? Set x equals 0 to find the y-intercept. Set y equals 0 to find the x-intercepts. Number 2, stationary points. We just learned how to find max and min points. Mark these on your graph. Number 3, behavior. What happens as x goes to infinity? Does it go up or down? This depends on the highest power. Let us look at example 5, sketching. The question is, sketch y equals x squared minus 4. Step 1, intercepts. Y-intercept. Set x equals 0. Y equals 0 squared minus 4. So y equals negative 4. Point is open, bracket 0 comma negative 4, close bracket. X-intercepts. Set y equals 0. 0 equals x squared minus 4. So x squared equals 4. X equals plus or minus 2. Points are open bracket 2, comma 0, close bracket, and open bracket. Negative 2, comma 0, close bracket. Step 2. Stationary point. Find dy dx. It is 2x. Set 2x equals 0. So x equals 0. At x equals 0, y equals negative 4. So there is a minimum point at open bracket 0 comma negative 4, close bracket. We know it is a minimum because the second derivative is 2, which is positive. Step 3, shape. The coefficient of x squared is positive 1. This means it is a U-shaped parabola. Sketch, draw a U-shaped parabola. It crosses the x-axis at negative 2 and 2. It has its minimum at 0 comma negative 4. This gives you a clear picture of the function. Now let us move to section 7, linear kinematics. This is a very important application. Differentiation connects the variables of motion along a straight line. Here are the variables. T equals time in seconds equals displacement in meters. This is the position. B equals velocity in meters per second. This is how fast it is moving. O equals acceleration in meters per second squared. This is how fast the velocity is changing. Here are the relationships. Velocity is the rate of change of displacement. So, V equals d s dt. You differentiate displacement to get velocity. Acceleration is the rate of change of velocity. So, A equals dv dt. You differentiate velocity to get acceleration. Also, a equals d squared s dt squared. You differentiate displacement twice to get acceleration. Note, to go from a to v to s, you use integration, which is the reverse of differentiation. But for now, we focus on differentiation. Let us look at example 6, kinematics. The question is, a particle moves such that its displacement s meters after time, t to the seconds, is given by s equals t cubed minus 6t squared plus 9t. Part 1. Find the velocity at t equals 2 seconds. Part 2. Find the acceleration at t equals 2 seconds. Part 3. Find the time when the particle is momentarily at rest. Solution. Part 1. Velocity. Velocity v equals d s dt. Differentiate s with respect to t cubed becomes 3t squared. Minus 6t squared becomes minus 12t. Plus 9t becomes plus 9. So v equals 3t squared minus 12t plus 9. At t equals 2, v equals 3 times 2 squared minus 12 times 2 plus 9. 3 times 4 is 12. 12 times 2 is 24. So v equals 12 minus 24 plus 9. 12 minus 24 is negative 12. Negative 12 plus 9 is negative 3. So velocity is negative 3 meters per second. Part 2. Acceleration. Acceleration equals dv dt. Differentiate v with respect to t. 3t squared becomes 6t. Minus 12t becomes minus 12. Plus 9 becomes 0. So a equals 6t minus 12 at t equals 2. A equals 6 times 2 minus 12. 12 minus 12 is 0. So acceleration is 0 meters per second squared. Part 3. At rest. At rest means the velocity is 0. The particle is not moving. So set v equals 0. 3t squared minus 12, t plus 9 equals 0. Divide by 3 to simplify. T squared minus 4t plus 3 equals 0. Factorize. We need numbers that multiply to 3 and add to negative 4. Those are negative 1 and negative 3. So open bracket t minus 3 close bracket times open bracket t minus 1 close bracket equals 0. So t equals 1 second or t equals 3 seconds. Answer 1. V equals negative 3 meters per second. 2. A equals 0 meters per second squared. 3. T equals 1 second and 3 seconds. Please write that down. Remember, at rest means velocity is 0, not acceleration. Now, I want to warn you about common mistakes students make. Section 8. I want you to pay close attention here. These are the traps that catch students in exams. Mistake number 1. Tangent versus normal. Using the same gradient for the normal instead of the negative reciprocal. Correction. Normal gradient is negative 1 over m. Perpendicular means negative reciprocal. Mistake number 2. Stationary points. Finding x but forgetting to find the corresponding y coordinate. Correction. A point has 2 coordinates. Always find y. Mistake number 3. Classification. Confusing the signs for max and min. Correction. Positive second derivative is minimum. Smile. Negative second derivative is maximum. Frown. Mistake number 4. Kinematics units, forgetting units like meters, meters per second squared. Correction. Always write the units. They are part of the answer. Mistake number 5. Small changes. Using delta y equals dy dx without multiplying by delta x. Correction. Delta y equals dy dx times delta x. Do not forget the step size. Mistake number 6. Rest condition. Setting acceleration to 0 instead of velocity when finding when a particle is at rest. Correction. At rest means velocity is 0. Acceleration 0 means constant velocity. Now it is time for class evaluation. Section 9, I want you to pause the video and solve these in your notebook. Do not just watch. You must practice to learn. Question 1, find the gradient of y equals 2x squared at x equals 3. Question 2, find the equation of the tangent to y equals x squared at open bracket 1 comma 1 close bracket. Question 3, if y equals x cubed, estimate delta y when x equals 2 and delta x equals 0.1. Question 4, find the stationary point of y equals x squared minus 6x and state its nature. Question 5, given s equals 4t squared, find the velocity at t equals 3. Take your time. Write down your steps. Do not rush. I will wait for you for your assignment. Section 10, please do these at home. Question 1, find the equation of the normal to the curve. Y equals 3x squared minus 1 at the point, open bracket 1 comma 2 close bracket. Question 2, the radius of a circle is increasing at a rate of 0.1 centimeters per second. Find the rate of increase of the area when r equals 5 centimeters. Question 3, find the coordinates of the stationary points of y equals x cubed minus 12x and classify them. Question 4, sketch the curve y equals x squared minus 2x minus 3, showing intercepts and minimum point. Question 5 is a kinematics challenge. A particle moves with velocity v equals 3t squared minus 12. Find the displacement s at t equals 3, given that s equals 0 when t equals 0. Hint, you will need to integrate. This last one is tricky. It goes backwards from velocity to displacement. Do not worry if you find it hard. Just try your best. Let us do a summary of what we learned today. Section 11. We learned about the gradient function. dy dx gives the slope at any point x. We learned about tangent and normal. Tangent has same gradient m. Normal has perpendicular gradient -1 over m. We learned about small changes. Delta y is approximately dy dx times delta x. We learned about stationary points. They occur where dy dx equals 0. d squared y dx squared greater than 0 means minimum. d squared y d x squared less than 0 means maximum. We learned about kinematics. V equals d sd t. A equals d v dt. Particle at rest when v equals 0. We learned about curve sketching. Use intercepts, stationary points, and shape to draw the graph. Here are some teacher's tips for WAEC. Kinematics is a common area of confusion. Emphasize that differentiation goes s to v to a. If the question requires finding s from v, briefly explain that this requires integration or anti-differentiation. For stationary points, encourage students to always state the coordinates open bracket x, comma, y close bracket, not just x. And always check your signs. Negative gradients and negative accelerations are very common. I know this was a long lesson, but you have done amazingly well. Applications of differentiation can be confusing because of the many rules, but you now have the tools to handle them. Remember, practice is the key. The more you practice finding tangents and solving kinematics problems, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you are stuck on, please comment down below. I try to answer as many as I can, and remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching, keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.